All right, so I had some requests to review some things from 5.3, and so I'm going to look at a couple of questions. These are questions about word problems with functions. And so I'm going to take a look at two of them, and hopefully this will help you to kind of get the process that we're going to use in order to help us understand what to do with these. I think probably the math you're going to be good with. I think mostly it's about reading a word problem and then interpreting. So police use the formula V of L equals the root 20L to estimate the speed of a car in miles per hour, based on the length L in feet of its skid marks when suddenly braking on a dry asphalt road. At the scene of an accident, a police officer measures a car's skid marks to be 243 feet long. Approximately how fast was the car traveling? When I read this, the first thing that I notice is I ask myself, well, what are the quantities that are actually being compared here? Right? Basically, what a function does is a function compares two quantities or two variables, call them x and y, or in this case, v and l. Okay? And then what exactly are they comparing if I'm looking at a word problem? So this one is asking me how fast was the car traveling, and the value that it gave me was the measure of the car's skid marks to be 243 feet long. So that's kind of an indicator to me that those are the things that are being related. Now, if I go back up here, please use the formula V of L equals root 20L to estimate the speed of a car. So what it's doing is it's estimating the speed of the car. What that means is that's the function. So V is the speed of the car. Okay. Now, in miles per hour, based on the length L, oh good, in feet of its skid marks when suddenly braking on a dry asphalt road. Oh, so L is the length of the skid mark. Okay, cool. Well, that actually is pretty much going to give me what I need. Now what I want to do is I want to say, well, what do I know here? So V of L, the police officer measures the car's skid marks to be 243 feet long. Well, if L is the length of a skid mark and we've got the measure of a skid mark, L is going to equal 243. Then it wants to know approximately how fast was the car traveling. Well, V is the speed of the car, right? How fast it's traveling. So that's going to be the unknown. So what we're looking for is going to be V of 243. And so we'll use how we understand function. That's just going to plug in everywhere we see a 243 or an L, excuse me, we're going to put in 243. Okay? So this is then going to equal the square root of 4,860. When we go to our calculator, that ends up giving me 69.714 miles per hour. That's how fast it's traveling. Okay, let's try it again. One of the people involved in an accident says that the car was traveling 60 miles per hour when he braked. Okay, so in this case, we now know V of L. V of L is going to equal 60 because V is the speed at which the car travels. So now what we're going to do is we're going to use that relationship again. 60 equals the square root of 20L. And in this case, L is the unknown. That's how long the skid marks are, or how long they should be. So we're now just going to, in order to solve this one, we'll take 60 squared is going to equal the square root of 20L squared. Okay, so that's then going to give me 3,600 will equal 20L. And so L will equal 180 feet. Right? Our values are in terms of feet. That's it. Okay, a couple things just to make sure we got this. Remember, if I want to get rid of, if I'm trying to isolate a variable and I have a square root, I'm going to square both sides. And that's how I ended up with the 3,600. And then we just go in, we're going to divide both sides by 20. And that's going to give me L. Okay, let's try another one. Suppose that the formula y equals 2.7 root x plus 15 models the percent of U.S. adults who are obese by federal guidelines. Ooh, well that tells me it models the percent of U.S. adults who are considered obese by federal guidelines. So y is the percent of obese U.S. adults. And then it says where x is the number of years after 83. X is the number of years after 1983. Okay. Now, and then it gives us some other information. In this equation, y is already converted from a decimal. So for example, 55% obesity rate would correspond to y equals 55. So that's important because we don't want to change it and make it y is, oh, it's 5,500%. That doesn't make any sense. So what we want to do is we want to make sure that we understand what our numbers represent. According to this formula, in what year was the obesity rate 19.7%? So what that is, that's y equals 19.7. Why? Because y is the percent of obese U.S. adults. Okay, so y is 19.7. And then I'm just going to solve for x to get the number of years after 1983. And then we're going to do something with it real quick afterwards. Okay, cool. Subtract, we end up with, we're going to subtract 15 from both sides. That gives me 4.7 is equal to 2.7 root x. All right, then we'll divide both sides by 2.7. So 4.7 divided by 2.7 is going to equal 2.7 divided by 2.7 root x. And that gives me that root x will equal 1.7407, and then it ends up being repeating. And then we just need to multiply, we need to square it. Squared. And that gives me that x will equal 3.03018 years. By the way, years after 1983. So if you notice, here's the thing, right? This is going to say, according to, in what year was the obesity rate 19.7%? Well, it's going to be 1983 plus 3.03018, which is 1986. So in 1986, the obesity rate turned to 19.7. So I hope that helps to explain these, okay? Basically, the trick here is to make sure that you understand how the different values are being defined, okay? Then, essentially, it's plugging it in, figuring out what values are you given, what values are you looking for, and then utilizing the function in order to solve them.